Hello everyone, Assalamu alaikum. I hope that you all would be fine and doing absolutely great. My name is Nimra Hanif. In this video, I am going to explain different tests for the functional groups. So let's get straight into the topic. Okay, so before going towards the main section of our topic, we should know that what are the functional groups, what is the basic definition for the functional group. In organic chemistry, a functional group are specific groupings of atoms within molecules that have their own characteristic properties regardless of the other atoms present in a molecule. The properties of a compound are largely determined by the functional group. So we can say that functional group is a specific group of atoms or bonds within a compound that is responsible for the characteristic chemical reactions of that compound. Some of the common functional groups present in organic compounds are as follows. So let's see what are the tests for the identification of the functional groups. Test for unsaturation. So the first test for the unsaturation is bromine water test. We'll take the compound in a test tube, then add 2 ml of distilled water, shake the test tube, add 1 to 2 drops of bromine water, then shake. We will observe that if the orange color of bromine water disappears, it indicates unsaturation, and if the orange color of the bromine water doesn't disappear, it indicates saturation. Second test for the unsaturation is Beer's test. Dissolve a little of the organic compound in about 2 ml of water or acetone in a test tube. Add 1 to 2 drops of alkaline solution of potassium permanganate and shake the mixture. Decolorization of the pink color of potassium permanganate indicates unsaturation. If the pink color of potassium permanganate doesn't disappear, it indicates saturation. Test for carboxylic acids. So the first test for the identification of the carboxylic group is sodium hydrogen carbonate test. To 1 ml of organic liquid in a test tube, add a pinch of sodium bicarbonate. A brisk effervescence indicates the presence of carboxylic group in the organic compound. The second test for the identification of the carboxylic group is ESTER test. Take about 0.1 gram of the organic compound, 1 ml of ethyl alcohol and 1 to 2 drops of concentrated H2SO4 in a test tube. Heat the reaction mixture on a water bath for about 5 minutes. Pour the reaction mixture in a beaker containing water. A fruity smell indicates the presence of the carboxylic group in the compound. Test for phenolic group. So the first test for the phenolic group is litmus test. Take the compound and add 2 to 3 drops on the blue litmus paper. If the color changes to red, phenolic group may be present. The second test for the identification of the phenolic group is test with ferric chloride experiment. The compound is dissolved in 1 ml of alcohol or suspended in water and add 1 or 2 drops of dilute ferric chloride. So what we will observe is a prominent color change other than the yellow color of ferric chloride is obtained, usually blue or violet, in some cases red or green. So we can infer that phenolic group is present. Test for alcoholic group. So the first test for the identification of the alcoholic group is sodium metal test. Take about 1 ml of the given pure liquid in a dry test tube. Add about 1 gram of anhydrous calcium sulfate and shake well to remove water. Filter the liquid to another clean dry test tube and add a small piece of sodium metal. A brisk effervescence due to the evolution of hydrogen gas indicates an alcoholic group. The second test for the identification of the alcoholic group is ESTER test. Take 1 ml of the given liquid in a clean dry test tube, add 1 ml of glacial acetic acid and 2 to 3 drops of concentrated sulfuric acid. Warm the mixture on a water bath for about 10 minutes. Pour it into about 20 ml of cold water taken in a beaker and smell. A fruity smell indicates the presence of an alcoholic group. Test for halogens. We will take the given compound, add sodium fusion extract is acidified with dilute nitric acid, boiled the test tube, then cooled it and silver nitrate solution is added. If the white precipitate soluble in ammonium hydroxide, chlorine is present. If the cream colored precipitate is soluble in ammonium hydroxide, bromine is present. And if the yellow precipitate is insoluble in ammonium hydroxide, iodine is present. Test for aldehydes. So the first test for the identification of the aldehydic group is Schiff's test. Dissolve about 0.5 gram of the given compound in alcohol in a clean test tube. Add few drops of Schiff's reagent. Shake and note the change in color. Appearance of pink, red or magenta color confirms the presence of aldehydic group. Second test for the identification of the aldehydic group is Tollen's test, which is also known as silver mirror test. Place 1 ml of silver nitrate solution in a clean test tube and add few drops of dilute sodium hydroxide solution. A brown precipitate forms. Now add dilute ammonia solution dropwise until the brown precipitate of silver oxide just dissolves. To this add 3 to 4 drops of the given liquid and warm the test tube on a water bath for about 5 minutes. A shining mirror confirms the presence of the aldehydic group. Test for ketones. So the first test for the identification of the ketonic group is m-DINITROBENZENE test. Place 0.5 ml of the given liquid or 0.5 gram of solid in a clean test tube and add about 0.1 gram of finely powdered m-DINITROBENZENE. Now add about 1 ml of dilute sodium hydroxide solution and shake. Appearance of violet color which slowly fades confirms the ketonic group. The second test for the identification of the ketonic group is sodium nitroprusside test. Take a pinch of sodium nitroprusside, add 1 ml of distilled water and then add 0.5 gram of the organic compound. Shake the test tube and add sodium hydroxide. A red coloration indicates the ketonic group. Test for the carbonyl group. First test for the identification of the carbonyl group is 2,4-dinitrophenylhydrazine test. Take 0.5 ml or 0.5 gram of the given compound in a clean dry test tube. Add rectified spirit until the compound just dissolves. Now add a few drops or 2,4-dinitrophenylhydrazine solution. Cork the test tube, shake the mixture and allow it to stand for 5 minutes. Formation of yellow or orange crystals indicates the presence of the carbonyl group. Second test for the identification of the carbonyl group is sodium bisulphate test. Take 2 ml of saturated solution of sodium bisulphate in a clean test tube and add 1 ml or 1 gram of the given compound. Cork the test tube, shake and leave it for 15 to 20 minutes. Formation of crystalline precipitate confirms the carbonyl group. Test for amines. So the first test for amines is solubility test. Take a small amount of the given compound in a clean test tube and add 2 to 3 ml of dilute hydrochloric acid. Shake and note the solubility. If the compound is soluble, it may be an amine. Second test for the amines is litmus test. Place a drop of the given liquid or a pinch of the solid on the moist red litmus paper and note the change in color. If the color changes to blue, it may be an amine. Thank you for watching the video. I hope that all of you understand the topic. Allah Hafiz.